Hello everyone, I am Dr. Sunil Kumar Srivastava. Today in this video lecture, I am going to discuss about partial differential equation, especially formation of partial differential equation. In this video lecture, we learn about what is the partial differential equation, what is basic definitions, and what is the degree and order of the partial differential equation, and what are the various methods for the formation of partial differential equation. So, in equation of this form, a differential equation involving partial derivative with respect to more than one independent variable is known as the partial differential equation. ऐसा कोई डिफरेंशियल इक्वेशन हो जिसमें डिपेंडेंट वेरिएबल हो, इंडिपेंडेंट वेरिएबल हो, मोर देन वन इंडिपेंडेंट वेरिएबल्स हो और उसके पार्शियल डेरिवेटिव्स इन्वॉल्व होते हों, that equation will be known as the partial differential equation. Generally, we take x and y as the independent variable and z as taken as the dependent variable. Then following notations are very useful. So we have del z by del x and del z by del y, first order derivative. So we denote here del z by del x is equal to p and del z by del y is equal to q. And second order derivative del 2z upon del x2 is denoted by r, del 2z upon del x del y is denoted by s, and del 2z upon del y2 is denoted by t. For examples, some examples of the partial differential equation. First of all, we have the taken here del z by del x plus del z upon del y is equal to k. This is the examples of the partial differential equation, and also we have the examples del 2 u upon del x2 plus del d u upon del y2 plus del t u upon del z2 is equal to 0. These are the partial differential equation. Now we are going to talk about the order of the partial differential equation. The order of the partial differential equation is the highest order partial derivative involved in the partial differential equation, and degree is the degree of highest order derivative present in the equation. In the previous examples, these are the differential equation of first order and first degree. This is the partial differential equation of second order but of first degree. So this is the basic concept about the partial differential equation and its degree and its about its order. Now we are going to talk about formation of these partial differential equation. Especially there are two methods by which we can form a partial differential equation. First is that by the elimination of arbitrary constant, and second one is that by the elimination of arbitrary function. Next, by the elimination of arbitrary function, suppose we have the equation of the form function of x, y, z, ab is equal to 0. This is the general form of the partial differential equation with constants, where a and b are the arbitrary constants. Now, in order to eliminate the constant a and b, we differentiate the given equation one with respect to x and with respect to y, and we have two equations. First of all, the equation 1 with respect to differentiation of partial differentiation with respect to x, that is del f upon del x plus p del f upon del z is equal to 0, and second one is that del f upon del y plus q del f upon del z is equal to 0. An elimination of arbitrary constant from 1a into the resultant is the partial differential equation. Now we take live examples to clear this concept. Suppose we are going to form the partial differential equation by the elimination of arbitrary constants from the function z is equal to ax plus by plus of ab. Now here the solution is given solution is z is equal to, in the solution we have taken z is equal to ax plus by plus of ab. Now differentiating one partially with respect to x. Differentiating one partially with respect to x. The partial differentiation to x means we have to differentiate with respect to keeping y and other variables as a constant. So we have del z by del x is equal to a, that is equal to p, and del z upon del y is equal to q, that is equal to b. Now we have here a is equal to p and b is equal to q. Now putting these values in the given equation, that is elimination of constant from from 2 and 1, we have the equation of the form z is equal to px plus qy plus of pq, and which is the required differential equation. Now next we have another example. Form the partial differential equation by eliminating arbitrary constant z is equal to x plus a, y plus b. So we have the given solution z is equal to x plus a, y plus b. Differentiating one partially with respect to x and y, we have here del z by del x is equal to p, that is y plus b, and differentiating again z with respect to y, we have x plus a. So we have see here y plus b is equal to p and x plus a is equal to q. Now just putting this result in equation number 1, we have the relation z is equal to pq, and this is the required partial differential equation. So in this way, by elimination of arbitrary constant, we can form the partial differential equation. Now we can discuss the second method by the elimination of arbitrary function. In this case, let f is the function of v. Let f is the function of uv. Here there's some mistake here, but denote here let f is the function of uv is equal to 0. Now differentiating one partially with respect to x and y, we have here we see f is the function of uv, u is the function of x, y, z, and z is the function of x, y. So we differentiate with respect to x. So here function f will be differentiated first with respect to u and u with respect to x. Then u differentiate with respect to z and z with respect to u, plus f with respect to v, plus v with respect to x, plus v differentiate with respect to z and z with respect to x. So we have the equation of the form del f upon del u by del x plus p del u upon del z plus p f del f upon del v, del f del v upon del x plus p del v upon del z is equal to 0. This is equation number 2. And similarly differentiating with respect to y, we have del f upon del u upon del y plus q del u upon del z plus del f upon del v upon del y plus q del v upon del z is equal to 0. And elimination of these derivatives del f upon del u and del f upon del v from the equation 2 and 3 will generate and will give the partial differential equation. Now we take an examples. Form the partial differential equation by the elimination of arbitrary function. From the arbitrary function is that z is equal to function of x square plus y square. Now in the solution we have here z is equal to function of x square plus of y square, and that is equation number 1. We have to eliminate the function here. So we differentiate the given equation 1 with respect to x and y partially, and we have here del z by del x is equal to p. Here f is a differentiate with respect to s, give f dash, and x square is differentiate, here we give 2x. And similarly we have the result differentiating with respect to y, we have del z by del y is equal to q. Same way differentiation, we have differentiation of f is equal to f dash and differentiation of y square is equal to 2y. So we have two equations 2 and 3. Now we have to eliminate the function f from the equation 2 and 3. So we have divide. अगर हम इन दोनों इक्वेशन 2 को इक्वेशन नंबर 3 के साथ डिवाइड कर दें तो वी कैन डिलीट दिस फंक्शन. तो इन दिस केस वी हैव द रिजल्ट p upon q is equal to 2x upon 2y, and on solving we have yp plus xq is equal to 0, and which is the required solution of differential equation, which is the required differential equation. Now we have another examples. Form the partial differential equation by the elimination of arbitrary function. Here function of f x square minus y square comma z minus xy is equal to 0. Now in this solution the given partial differential equation is, first of all we have to write the given partial differential equation is here f of x square minus y square zx minus y is equal to 0. Let here u is equal to, let us suppose that u is equal to x square minus y square and v is equal to z minus xy. Then this given equation can be written in the form function of u comma v is equal to 0, and we denote this equation as the equation number 1. Now differentiating 1 with respect to x and y, we have the equation of the form just del f upon del u by del x plus p del u by del z plus del f upon del v upon del x plus p del v upon del z is equal to 0, because here f is the function of u comma v, u is the function of x, y, z, and z is also function of x comma y. So we are apply here chain rule. Now putting all these derivatives, this like as del u by del x, here we have 2x, del u by del z values, and del v upon del x, del v upon del z in the equation. We have the equation 2, that is the del f upon del u 2x plus del f upon del v minus y plus q is equal to 0. This is equation number 2. And again differentiating equation number 1 with respect to y, we have the relation and after putting the values del u upon del y, del u by del z in the above equation, we have the equation number 3, that is del f upon del u 2y plus del f upon del v minus x plus q is equal to 0, that is equation number 3. Now we have to eliminate this function from the equation relation 2 and 3. So just eliminating the function del f, eliminating the derivative function del f upon del u and del f upon del u from the relation 2 and 3, we just write the equation in the form, that is the determinant 2 by 2. In the first row we have write the coefficient of del f upon del u and del f upon del u from the equation number 2, and in the second row we have to write just the coefficient of del f upon del u and del f upon del v from the equation 3, and this is equal to 0. And just we open this determinant, suppose open this cross multiplication, this one and minus this one, so we have here, and after simplification simplify and simplify the results, and remaining the terms is the xq minus yp is equal to x square minus y square, and this is the required partial differential equation. So just we have to eliminate this function by this determinant and open this, simplify, remaining will show the given partial, the required form of the partial differential equation. So this is the method by we can form the partial differential equation by the elimination of arbitrary function. This is the most important topic of the engineering mathematics 2, and this was the basic concept about the partial differential equation, about their formation. Now we have to thank you.